Hi, welcome to this tutorial on STAAD.Pro steel design to AS4100 1998 steel structures, and specifically highlighting how to design members using the P-member design method. Before we get started, it's very important for you to, before you start using this AS4100 module in STAAD.Pro, that you make sure you spend some time reading the technical manual, specifically the section related to AS4100, because you need to understand all the methods, assumptions, and limitations in the program, so that you can make sure that you're using it correctly, and two, that you get the right design outcome.
So what I'm going to do here is I'm just going to show you a very simple example of a member and what the process is to design that to AS4100. So I'm going to open up a model that I've already prepared, and you'll see in the screen there it consists of 3 analytical members, 1, 2, and 3, and then we've got a pin support at the left end and a roller at the right. Quickly showing you that in the rendered view, you'll see there I've assigned an Australian section, so I think I've assigned a 250 UB to that section, so it's pretty simple. We've also assigned some loads. We have a self-weight load case, we have a dead load case with 2.1 kilonewtons per meter. We have a live load case of 3.6 kilonewtons per meter, and then we have a combination using the repeat load of 1.2 self-weight, 1.2 dead load, and 1.5 live load. So if I just proceed to analyze this member and go to the post-processing mode, you'll see that if I turn on my bending moments, you'll see that's the bending moment shape as you'd expect for a simply supported beam. And if I go view the values, I can just turn on some of those values, and you can see there for the combination we've got a maximum moment of 37.3 kilonewton meters. Okay, so once that has been done, I should just mention that's just a standard linear elastic analysis. What we're going to do now is we're going to go and create what's called a P-member, and a P-member allows you to essentially group a bunch of analytical members into one member called a P-member for design. So the first thing I'm going to do is I'm going to go select these 3 analytical pieces, and you can see on the left here there's a whole bunch of tools relating to physical members or members. And if I select on here form member, that will form a P member. The other way I can do it is once I'm in the GUIs, I can right click and hit form member. If I go into the labels, I should say, and I look at under physical members and I turn on member number, you'll see that these 3 members have been assigned to physical member M1. Now, there are some rules that go along when you create a P member. The first one is that it must form a single continuous line, so I cannot select 2 analytical members that are broken and form a P member. Won't allow me to do that. Each analytical piece must be orientated in the same direction along that line. So in other words, if I go into the structural diagrams and the labels, I should say, and turn on the beam orientation, you'll see that these 3 members all have the same local axis direction. So that's the X local axis, the one shown in blue. So they're all pointing in the same direction, so that's allowed. If this one was pointing the other way, you wouldn't be able to form a P member. The other way you can also look at it is you can look at the start and end colors specified with green at the start and blue at the end, and you can see that they're all flowing in the one direction. Along with that, obviously, when you form the P member, you also have to have the same section size. So I think this is a universal beam with the same size. You have to have the same material assigned. So we have the default steel material, and also the same beta angle. And I think this one doesn't have a beta angle assigned. So I'll just turn off the start and ends there. One thing to note here is if we go into the STAAD editor, you'll see these two lines here where basically we've got a define member start command, and we've got analytical members 1 to 3, P member, and it's going to be called P member number 1. So I'll just quickly show you that that's how it's been defined in the input file. Now, once you've done that, you can, if you wanted to delete a physical member, what we have is we have a select physical member cursor. So if I select this cursor, you'll see that it'll highlight 3 analytical members when I click on one. Versus if I have the normal beam cursor and I just clicked here, I'd only select the analytical members underneath. So going back to the select physical member cursor, I'll select the beam, and if I want to delete that physical member, I just simply hit the delete key on my keyboard. And you'll get a dialog pops here, and I'll say yes, and you'll see that those physical member numbers have now gone, and it has been deleted. Obviously I'm going to want to put that back, but I thought I would show you another feature that's in STAAD.Pro. If you have a frame with a whole bunch of analytical members, you can use what's called the auto form member, and that will look for elements in straight lines that meet all those requirements that I discussed before in terms of the same section size, going in the same direction, same beta angle, and in a continuous line. So I'll click on auto form, and you'll get a message come up, and I'll say yes to that. And then if I turn on the members again, you'll see that that has automatically been signed to the P member M1. So it's just a different way of doing it. When you do this on a large structure, you'll want to review the physical members and make sure that they suit your design requirements. Okay. Now, once that's been done, well, we can move on to the AS4100 design module. So the first thing I'm going to do is I'm going to use that select physical member cursor again, and I'm going to select my P member. I'm then going to go to the top here and select AS4100 from the drop-down list, and then I'm going to define some parameters and assign it a command. But before I do that, it's very important that I turn on this toggle physical member mode button. When I do that, that means that any parameters or commands that I subsequently define will be applied to the physical member and not to an analytical member. And you'll see that later on. So I'm going to go define some parameters. There are some new parameters for the guys who have used it before, or for other people you can refer to the manual. This one here, for example, is for a load height factor, so I'm going to assume that the load is applied at the top flange of the steel beams, and I'm going to click assign. I'm also going to go and look at the SGR parameter, which is a nominal steel grade parameter. We have normal and high strength options. For normal, in this case for a universal beam, it'll be a standard 300 grade, or what one steel would call a 300 plus. So I'm going to go and assign that as well. And lastly, what I'm going to do is I'm going to go down to this track parameter, which controls the level of detail of output, and I'm going to select 2 and assign that as well. Now, you'll notice in the tree structure here that these are the 3 parameters I've assigned, and you'll see in brackets that they have physical after them, and that's how you know that they've been assigned to that physical member, not to the analytical member. The other values, parameters, I'm going to leave as default values. You can check the code, the manual out to see what the other ones do. Okay, so the next thing I'm going to do is I'm going to also go and add then a check code command. And so this is only going to check the capacity of the existing members. It's not going to design them for you. So all I have to do then is go and assign them. I'm going to use assign to view and say yes, and you'll see that that's now been assigned. And you'll also notice that that check code has a physical in brackets after it to indicate that it's being applied to that the P member there. One other thing I'll show you before I do anything else is we'll go back into the STAAD editor, and if we go down to the portion where we've defined our parameters, so we've got code Australian, which is the same as it is for the design previously, but you'll notice that these three parameters, design parameters, as well as the design command to check the code, specifies a P member keyword instead of a member keyword. So that's just something. That's how the STAAD editor handles the P member design. Okay, so once you've done that, you've basically set up your defined parameters. You've given a design command. You can go and run it. So I'm going to go to Analyze and say Run Analysis, and that worked fine. And then I'm going to go view the output file. Okay, and then you'll get your pop-up as per usual. I go select Steel Design, and you'll see here that compared to what was there previously, there's a lot more calculations provided. So you'll see that you'll get a couple of pages worth of calculations. Essentially what you get is you get some design notes at the top. You'll get a design summary, which will tell you the what section and materials applies, the governing load case, which is number 4 in this case, the governing criteria, the governing ratio, and you can see in this case the member has actually failed. It lists the section properties, the material properties. It then goes and looks at bending capacities. It looks at the section capacity as well as the member capacity, which takes into account lateral torsional buckling. It does a section check on the shear capacity. It looks at the section capacity and compression for axial load. It looks at the member compression capacity taking into account buckling. It also does a section tension capacity check. If there's a tension load that is being applied, you can see there is none in this case, it's got NA. It also does a combined bending and axial check for both the section and for the member. And you'll see there's all the code references there, so you can easily follow what's going on. So that's basically the process. Just to summarize, it's strongly recommended that you use the P member design method, even if you're designing one single analytical piece. You may have one beam made of one analytical piece. In that case, you should select that one piece, right-click, and use the form member command, and then define parameters and assign commands to that P member. And as mentioned at the beginning of this this video, make sure you check out the AS4100 section of the technical manual. It provides a lot of information about the assumptions in there, how to define the parameters, some things to look out for, how to handle second order effects. The list goes on. So I hope you found that helpful, and happy designing. Thank you.